Exploited, the Cyber Truth, a podcast by RunSafe Security.
Welcome back, everybody, to Exploited, the Cyber Truth. I am Paul Ducklin, joined as usual by Joe Saunders, CEO and founder of RunSafe Security. Hello, Joe.
Greetings, Paul. Great to be here. Look forward very much to this conversation today with DJ.
Yes, me too. And you're playing on your home ground today, aren't you? Not on the road for once, so that's great for you. What's really great is the guest we have today, who is Danielle Jablanski, who goes by DJ. You can probably work out why. So we shall be referring to her as that. We shall be calling her that throughout the podcast. Now, Danielle, I'll leave you to introduce yourself. You have quite a complicated job title and you have an interesting background that I think our listeners would like to know more about. So it remains only for me to let everybody know what our topic is today. Now, it's quite a mouthful of a topic. It's quite dramatic sounding, but it is very, very important. And it is the cyber physical truth, what we get wrong about attacks on critical infrastructure. So for our listeners, when we talk about cyber physical systems, I guess other people may call them operational technology, OT, or industrial control systems. Some people will be familiar with SCADA, which is, I think, system control and data acquisition. Basically, the computers that are not laptops that help us get into Teams meetings, but the computers that drive things like pump rooms, welding machines, industrial robots, position construction devices, and so forth. So, DJ, why don't you start by introducing yourself and your background and how you came to be so passionate about cybersecurity?
Sure, I'll try to keep it pretty brief. So I work at an engineering firm. A lot of people call them EPC firms, engineering, procurement, and construction. We're kind of EPA, engineering, procurement, and architecture. We do a lot of the design work. We actually partner with a lot of the builders on the construction side, just depending on which sector we're working in. We focus primarily on rail. We have a buildings practice as well as water. We have our own integration service. And then we have standalone services in physical and cybersecurity, which is where I sit. So it's a center of excellence. And why I think that's unique and important to mention is that it's a hub and spoke model. So cybersecurity is not a standalone cost center or even an MSSP. We're completely vendor agnostic and we're not a reseller. And that was really important to me when I made the jump. So I do run the cybersecurity portfolio within the Safety and Security Center of Excellence. And that hub and spoke model allows me to do design work, procurement guidance, hardening guidance, but also standalone oversight on technical deployments for monitoring solutions on train sets. So it's really, really cool work that I get to do. Before I came to STV to kickstart this program, I was the OT strategist in the office of the technical director at CISA, the Cybersecurity Infrastructure Security Agency, under DHS, Department of Homeland Security. Before that, I was at a solution provider that does continuous monitoring in the OT space. And before that, I was actually an industry analyst. And my expertise was intrusion detection systems for industrial control systems, which has evolved into the continuous monitoring ecosystem today. Before that, I was in academia. I looked at cyber policy a lot. And even before that, I was a policy analyst looking at nuclear weapons technology and use, and really focusing on the cybersecurity impacts from upgrading and modernizing the way that we deploy and maintain and modernize nuclear weapon systems. So that's my nutshell background. But yeah, when I figured out that I loved this space, I really, really drilled in. And I also got lucky because the market itself took off. So I can't ignore the timing of it. It wasn't just a hobby horse. It was at a time where the market really started to pay attention to OT as well.
Yes, it's almost as though those of us who work in cybersecurity need to feel a tiny little bit guilty about it. Like, if only the industry did not need to exist because things were A, secure from the start, and B, we weren't facing so many money-making, politically manipulative state-level actors and all of that sort of stuff that puts us at risk. So, DJ, how does risk differ between IT, where we're concerned about, oh dear, I couldn't get into a Zoom meeting today, and OT or industrial systems, where you might be a little bit more concerned about, will my welding robot run amok?
Sorry, gotta find the mute button. So when we talk about risk, it's really interesting how this breaks down in cyber because there's this age-old debate between assets and functions. And this is something CISA tried years ago to discern, right? Critical functions are things that we rely on for the economy, for national security, right? The delivery of safe water, those kinds of things. Assets, of course, are the industrial control systems, the PLCs, the DCS systems, even potentially how far down does this go? Maybe it's the baggage claim, the motor that's running the baggage claim, right? It's a piece of equipment that's operating based on computer inputs that has a physical action in the real world. And so this kind of debate, I think we got lost a number of years ago on like, where does risk start and stop for assets versus functions? The reason that cyber physical is different, of course, from IT is two things. The assets themselves are built differently, and then their use in the world is different than computers, software, and email, right? So there is a physical risk to safety.
Yes, if you think about a train hammering down a railway track with
Right.
50 goods wagons all loaded to the teeth behind it, that's a little bit different from, oh dear, I had a 5-minute outage during which I couldn't make phone calls.
Yeah, and trains are actually modernizing a little slower actually in the communications in terms of how they run on the tracks and how they occupy the tracks and where the train, which part of a sensor actually knows where a train is actually evolving now. It's not, part of the industry 4.0 conversations we have in sectors like manufacturing. And so that's another breakdown is like different sectors are actually on a different journey. But so of course, cyber physical has like risks to safety, the environment. There's this potential for loss of life, especially like in the oil and gas industry, in manufacturing settings, in chemical, right? If there's a supply chain incident or even a factory level incident. Then we have another set of risks in productivity, efficiency, and just-in-time manufacturing. There was an incident in Japan that affected Toyota from one of their suppliers, and so it didn't actually hit their environment, but they have just-in-time manufacturing. Therefore, it did hinder their production. And then you have also intra-sector transactions, right? So a huge amount of electricity goes to water. So water requires electricity. A huge amount of water goes to healthcare. Healthcare requires water, clean water. And so you have that intra-sector transactions that is not as complex when we just think about IT systems. So this whole ecosystem of cyber physical across these sectors really underpins society and our modern way of life, touching critical products, resources, and services with these complex ownership models. So I wrote a piece for the Atlantic Council a number of years ago, and I did an iceberg model. It goes all the way down to the OEM level, which we haven't even touched on yet. And then you talk about the layers of things on top of that, right? Owners, operators, integrators that are completely unregulated, that might be the last touch point of what update gets pushed or what firmware gets replaced. And then within that ecosystem at the OEM level, you have tons of vulnerabilities, right? And you might have more vulnerabilities in one OEM product, not because it's more vulnerable and more risky, but because they actually have a better disclosure process or they have more components, right? So they actually have a larger inventory. Therefore, they're going to have more vulnerabilities. So a lot of things are not cut and dry, and it's difficult to then unpack that from a risk perspective and analyze all of that within one single context. Am I a chemical company with 50 sites globally? How do I square peg round hole this scenario with contextual information given all these different risk priorities? So again, back to the functions and assets, it's difficult to fully protect and prioritize functions and assets everywhere all the time, given those complexities, I would say, from a sector perspective, but also from that iceberg model. Everyone who might touch, deploy, access, and ultimately be responsible for the maintenance of these systems at an asset level.
I guess if you think about an iceberg vertically, given how far they go down below the surface, the bit that you can't see, then that raises an enormous issue in cyber physical and OT systems for supply chain risks, doesn't it? It's not just, oh, well, I pulled the wrong HTTP web fetching library into my web app. This, as you say, goes all the way down to the OEM layer and even below. In other words, what software of those bottom level OEM, the people who made the computer that turns the switch, that changes the pump, that adjusts the water, etc. So I guess we'll come back to the supply chain later if there's time, but it's very much longer and more involved and much more variegated than it has really become in IT. Would you agree with that?
I wouldn't say it's more variated. I just think it's a little bit more complex. I mean, you actually have more different types of systems in IT, right? So
Yes, I think that's what I meant. In other words, it's not just, hey, TCP/IP is the beginning and the end of all networking. It's much, much more complicated than that.
You actually have this like marriage of communications data points and process data points or process variables, right? And those process variables actually dictate the logic in the process for whatever system is going to actually command and control and dictate what happens in the physical world at the layer 0, is what we call it in the Purdue model, the field level, where those actual instrumentation is taking place. So again, depending on the sector.
So this is not just, hey, I've clicked the button and now a series of things will happen that will take $4.99 off my credit card. Right. This is something has happened on a sensor over here in Ohio that might change the status of some regulator in a state 2,000 miles away.
Well, and what sensor we're talking about matters. So there's process anomalies, set points within the logic that can actually be implemented or implanted, depending on who's doing it, in a few different areas. So you have control logic, which is historically based on relay logic, which we've borrowed as a deterministic way to program control systems from electrical relays built on electromagnetic fields. These types of systems are what underpins the control systems that we talk about as PLCs and these different types of assets. So typically when we talk about communications risks to these assets, we just talk about access, lack of encryption, right? Passwords. We don't actually get to the engineered portion of these systems, which is that control logic, again, built on relay logic. So there is the potential to have a tailored attack that actually targets the programming function and variables that are defined within these systems. And so you can change the setting as a command to the system. You can actually change the parameters of the setting within the software setting for the product. So not just the set point of a desired value, but actually the threshold of available or allowed set points within there. And then you can otherwise manipulate the environment to evade detection. So say you were able to change those parameters in a way that made something that historically was not an acceptable set point acceptable because you've changed the parameters within the logic. You can then evade detection by also targeting something like a safety instrumented system, which we've seen in a couple different ways, so that the situation is not triggered on additional alerts within the environment. So you can create an unhealthy or an otherwise hazardous environment, and then also have an impact on another system that was actually determined by the programming to be able to alert on that environmental change or trigger. And then lastly,
so might an example of that be, say, that if you're an attacker, you might override some pressure limit in a boiler somewhere, but also manipulate the sensor so that it continues to say, oh, yes, it's 1.4 megapascals, when in fact it's now 3.6
so
or something.
You could do either. So the Stuxnet example, they actually were changing something over time slightly so that the actual set points were changing so that the centrifuges were spinning at a speed that they weren't supposed to spin at. But you also have the TriSys example where the safety instrumented system was targeted and it tripped multiple times. And so they were able to figure out that something was going wrong. But in that scenario, you wouldn't even detect some type of actual physical environmental temperature setting, something like that is unsafe. So you have kind of the production supply chain target, or the environmental safety will no longer be triggered and we can kind of do whatever we want. And we don't have to tell you that it's happening, because it's not being triggered either way. So if you're not investigating, it's not that the screen says everything is good and behind the scenes we're actually manipulating things. It's that you're not even looking at the screens. We're manipulating whatever we want to, and we're also making sure that it's not going to be identified to you within the parameters of your network. And so there's this other ability to slightly alter things over time without being discovered, right? Which could impact manufacturing.
Yeah. I guess there's also the issue that these specialized devices, many of them may be 5, 10, 15, 20 years old, even older, and they may have evolved and have been introduced from different vendors at different times for different purposes. So there's not necessarily the integration you might expect between, say, the pressure regulator and the pressure sensor. So the fact that they go out of kilter might never have been thought of as an important issue to design in to start with.
The interoperability between the systems themselves in a deterministic nature is actually pretty well designed and defined in terms of like the standards we have. OPC-UA is a good example. But the way that we do monitoring on these systems, because we have, some control logic is actually throwing out data captures, right? For a historian, this historical trend analysis essentially in milliseconds. So you have tons of data points, but if you're not actually analyzing that data in a comprehensive way, you're not going to see changes that would alter things if they're not being reviewed, right? And setting up some of those alert thresholds. So you have essentially these safe thresholds for your set points that dictate the command and control of the control logic itself. But then you have monitoring aspects on top of that for both data access communications, right? You want to know if a new device is on the network communicating. You want to know the average kind of device to device communications. You want to know if there's large bandwidth spikes, things like that. But you also want to know if there are set point changes, if there are process anomalies detected within those variables that should otherwise not be there, right? There's not a maintenance window. There's not a technician there to change anything within the software. And of course, in these heterogeneous environments, every piece of equipment actually comes with its own proprietary software as well. And so there's a number of touch points, but it does get very convoluted. Components are widely used across many different owner operators. We say that there's an average of 12 vendors per environment. That's hard to make specific because we're talking about different sectors.
When you say environment, would an environment be a
plant,
pump room or a whole factory?
Yeah, a whole factory, a plant, electric utility, potentially, probably less than 12, but maybe around 6 or 7. And so when we look at like supply chain type incidents, we're thinking, what is the potential SolarWinds type of impact we might see from like a supply chain software?
I'm trying not to smile and laugh because that is not funny, but it should bring a sort of, I guess, a wry smile to everybody's lips of just how dramatic the effect was.
Well, yeah, but the thing so I don't want to call it security by obscurity because that's not quite the right label, but having these multiple vendor systems in an environment does mean that a vulnerability or even a 0-day in one of those vendors should not take down your entire environment, right? Because that vendor is only one component, depending on your crown jewel analysis and your critical function, right? What's mission critical, what's not, and how you've tiered out those systems. So there's a debate actually within the industry on whether or not we should reduce the number of vendors or make these environments more homogeneous. I actually don't think that that's a great idea. I think that consolidation and interoperability across industrial environments increases interdependence and creates more single points of failure. But
okay, so you're against when you say you're against the, hey, let's have everything in all our eggs in one basket.
I mean, if you think about cloud providers, there are 3 major cloud providers. So if you have mission critical functions that rely on one of the 3 cloud providers and that cloud service is no longer available, and you have a 24/7 operation that requires uptime, requires availability, that's an obvious single point of failure. So why would we want to create more of those?
I am an Outlook user for my sins. Yeah. And as we're recording this, it's a day after, an outage that in my life was, I must admit, essentially insignificant. But the problem was that Microsoft kept saying, we think we found the problem. We think we fixed it. We haven't. Oh, no, it's reverted. Oh, there's a problem. Oh, let's start again. And you think that's just fixing their email system.
Well, and CrowdStrike is a great example. So it wasn't a targeted incident, but I was at CISA at the time and I couldn't access my computer. And so
yes, that was much worse because that caused a boot loop, didn't it? Where the crash happened so soon in a kernel driver that had not been tested in the real world at all. Just some automated, we think this software is good enough, but in fact, the testing didn't look for a buffer overflow. They wrote a 21st item to a 20 entry buffer, computer reboots. And the weird thing there was that one of the ways to fix it apparently was just to wait and wait and wait. And eventually you might get lucky and you might get the update before it crashed again, which is not a great way to recover something like a railroad network or a factory or a hospital. Hey, let's just wait. The next 20 operations might turn out really badly, but then the surgery will be restored to normal. That's just not acceptable.
Important to mention. So we talked about safety interconnected systems that are supposed to alert on unsafe parameters or environmental factors, and there's different sensors that are associated with those. There are also fail-safes, right? Fail-safe procedures and processes that are also programmed into these, and so a very responsible asset owner will always have some type of sandbox or testing environment before they push anything. I was more alluding to like the third-party reliance, and you see this across like telcos and other kind of third-party providers, especially in the MSSP space, right? So that's kind of where we look at it in terms of all of the different control systems that might be impacted. But then the other risk is centralization risk. And we talk about that either with one type of product or with an entire sector relying on the same third-party provider, right? So those are two things that have not been widely analyzed, I don't think, across all of these different OT sectors. Of course, we have 16 critical infrastructure sectors in the US. Years ago, when I was a market analyst, I actually did some numbers with a building stock database that we had at the consulting firm that I was at before this one. And I was able to estimate that within 4 sectors, energy, water, critical manufacturing, and food warehouses. So not production, but like so not farming, not agriculture, not cattle and dairy, but just where the product goes in the factories and it's basically packaged. 8 million facilities worldwide was the estimate from this database. So,
and that's from a quarter of the
exactly 4 of the sectors.
That are considered critical. That's a quarter of industry.
And it's a subset as well. So critical manufacturing was estimated to be a certain percentage of overall manufacturing per region. So in Asia and North America, it was high. In Europe, it was a little bit lower, things like that. So there were like pretty good statistics applied to it. But the centralization risk, given that attack surface, if you want to look at it that way, is very, very difficult to study and analyze. And then when you get back to the OEM kind of version of this, understanding where in the world all of these OEM systems from each of the vendors has been deployed, you can probably count that pretty well based on what they've sold and some of that historical data. But because the chain of custody is so broken, which is not the OEM's fault, right? They deploy something, they sell it, and people buy it and use it. And so in that middle ground of being bought, used, potentially resold, different updates, different integrators, different configurations, different security things applied, enabled, or potentially disabled, understanding the provenance issue is something that I've been really passionate about in my own research because it really muddies the water. And so we want to solve these problems, but I think the centralization risk is unpredictable in that way, both in terms of one component that might take down multiple asset owners from different sectors, as well as understanding the one service, software, or product that an entire sector, has really rallied around. And I think that goes back to my heterogeneous versus homogeneous, strategy approach. I don't think we should consolidate for the sake of consolidation. I think it should be strategic, and we should understand our interdependencies before we create accidental single points of failure. And then that centralization risk is actually realized inadvertently by us trying to reduce our reliance on these different vendors, right? It's a chicken and an egg problem, I think.
I'm struck just by all the layers that we're talking about that DJ you've pointed out, and that you even can extend into the software supply chain. As we say, there's the OEM, then there's maybe there's their own developers, there's third-party developers, the open source software. And if you think about 16 sectors, you think about just in those 4 that you mentioned, there's 8 million plants. You think about the layers within their OT infrastructure itself, and then you think about all the layers in the software supply chain, and you keep using a word that is obviously very, very important, the determinism in these systems so that they operate reliably as expected and do the functions very well that they ought to do. So it's quite compelling, I think, when you think about all these different dimensions, all these different layers, to think about then the software problem these organizations have. I agree with you. It shouldn't be a homogeneous environment. Imagine with all 8 million manufacturing plants being identical. That'd be a scary, scary thought. But at the same time, yes, when you have a very heterogeneous environment, then what you have is a distribution problem of software and how you apply updates, and updates getting applied to all these devices that do then stand the test of time far beyond what a normal cloud workload would, right? And so these gadgets, these devices, these systems, these sensors, these cyber physical items, they are out there 5, 10, 15, 20, 30 years, maybe in some cases. And then, then you start to layer all the different versions of the software on those devices. So it starts to become pretty complex, and it's a very, very interesting space because, as you said up front, DJ, the consequence is so, if something goes wrong, is quite high. It could be an economic loss, but it certainly could be life and death, as you suggested, or, simply the reliability of distributing things that we all rely on in everyday life. So I'm just struck by all the layers in all the directions and thinking about what the software update challenge is given a heterogeneous environment.
That's what kind of made me raise that assets versus functions, right? Because we can all kind of figure out deterministically which functions are so important, but then we can't just go patch all the assets that those functions rely on, right? So it's not that easy. In my own work, and especially when I was doing strategy work at CISA, I really focused on network security, right? Because network security is something that the asset owner can fully own, but also there's so many partnerships involved. So my focus was always on legacy systems and effects-based analysis. And so effects-based analysis was always looking at an environment or a context and saying, what is the worst effect that could ever take place here, given our mission, given our technologies, given all of our assets, and given all of the programming, all of the functions, all of the set points, like what is the worst case thing somebody can do? Increase the chemical levels in water, it makes something blow up in oil and gas, right? What can happen here? And how do we reduce that risk and reduce the impacts or the severity of potential cyber aspects to creating those scenarios, right? So that's an effects-based approach. So it's always what I've looked at doing. Many processes and tools are involved in network segmentation. For years, I've said people act like segmentation is like flipping on a switch. It's not. And so there's a lot of key factors that are make or break the success or defense of a cyber incident. And so when I was at CISA, there's actually a team working on adversarial emulation. And in one of my first meetings, we did an offsite. I was there for maybe like 2 or 3 weeks. And the guy that was working on this stood up and he said, and a lot of our adversarial emulation work, when there's really, really good network segmentation, the attackers give up and move on. And then he moved on. And I was like, whoa, we need more data on that. But unfortunately, a lot of that data is in the marketplace. And so it's a vendor specific. Hey, we have this tool or we've deployed this honeypot and we've seen these effects in our adversarial emulation work. So at a strategic level, at an academic level, it's hard to grab those numbers because they're marketing numbers. And so that's not important. It hasn't been, I don't think there's a wide academic study of that. But I do know that there are good indicators out there that show proper segmentation does actually make adversaries give up sooner, which in theory, right, when you're looking at things like zero trust strategies, reducing the dwell time should reduce the severity of impacts, right? Because you're finding things faster, therefore they should be able to do less damage, right? That depends on the rest of your defense in depth strategy, but that's really where I've focused in on what you've alluded to, which is this like complex problem. How do you get around it? And then here at STV, I've really pushed a lot of our clients to not jump to purchasing capabilities, but really focusing on building competence and capacity before deploying really expensive tools, especially for segmentation, for data, for asset inventories, things like that. And so, in order to grow your continuous improvement, you have to understand those interdependencies, do some of that mapping exercise, really look at your legacy systems and understand that effects-based procedure, I would call it. And then build your own baseline and invest intelligently in all 3 categories, right? Competence, capacity, and capabilities to verify that your controls are working for you and not that you're just going to build a list of controls on paper that you may, institute to a varying degree. So that's kind of how I get around that.
Now, DJ, we've talked quite a lot, or we've alluded to segmentation, and which is, where you keep things that are supposed to be separate, so that they don't wander into each other by mistake. And we know from incidents like the Stuxnet virus back in the day that even having a physical air gap is not necessarily enough if someone is prepared to walk a USB key from one side of an office to another. But it seems that in the industrial control world, we're also running headlong towards what you might call desegmentation, with this thrust to go, hey, let's just connect the IT and the OT systems together so that I can sit remotely on my laptop and I can have a web app and I can go and look at what the human interface devices in some far-flung pump room look like. Maybe even I can press a button in my browser that actually causes the effect that would have required someone to go into the pump room and press a physical button in the past. And we did a podcast with Gabriel Gonzalez a few episodes ago. He's a well-known industrial device researcher who digs into cyber physical hardware systems to look for vulnerabilities. And he recounted how trying to break into modern automotive systems so that they could hack cars remotely, they kind of gave up bothering to do the equivalent of the Jeep hack back in the day. They just found an ill-configured MQTT server that basically gave them one server on the network wrongly configured, gave them complete control over an entire fleet of vehicles. They could monitor where they were going. They could track all the journeys, which is valuable information for a cyber criminal or a state-sponsored attacker. And they could actually tell the vehicles what to do remotely, all through a bug in one server that simply brought all these vehicles together.
Well,
how do you deal with that problem?
Network focus versus assets, right? So I think that there's kind of a general understanding that the network provides the access regardless. And so I think we're actually seeing kind of a wave of more network focus than asset focus. But your point on remote access is just one part of the picture. So there are all sorts of good reasons for data to flow in a network, not just remote access and limiting the need to go places to do things, to touch systems, right? For manufacturing, I have pulled up here the top 5 forecasting considerations. We never talk about forecasting. We talk about historian data and point in time data and all these captures and why it's important. I think it was Toyota in Europe was able to actually increase their efficiency, looking at tons of data points around how much paint they were wasting in their paint shop. Like really cool use cases for understanding very minute details about the process and the data points you can extract from that process to do good things. But we don't talk about forecasting enough. So a lot of these business use cases, just pulling from manufacturing, you've got economic forecasts, historical sales trends, supplier forecasts, seasonal changes in weather, and then business constraints, right? That's just for manufacturing. When you look at controlling the grid, interoperability of the grid, you have all these other complexities of the way we need data. And so I think we're looking at security from a network way, but we're not actually applying enough discretion around frivolous data and user access, because we think of that access as being remote control or having one use case.
Well, I like that term, frivolous data, because we have far too much of that in the modern world,
the amount of frivolous data in your network on top of user access. So even when we put out the mitigations at CISA, we'd always say, get stuff off the internet, look at network segmentation, and control your remote access, including from your vendors, right? And that's also how do we kind of do some of the components in the DMZ, access to your jump box, replicating jump boxes for multiple vendors, those kinds of things, right? There's all sorts of best practices out there, but you have to have strategies behind those best practices. And I think that's kind of a missing link that we're starting to evolve on when we look at network security. I've also seen, back to the capacity portion of my program, I've seen really, really, really well-resourced organizations deploy hundreds of thousands of dollars in security tools in their OT networks, and then their firewall rules are any. And so, I mean, and it's not really it's back to strategy. Have you done this, have you done the due diligence to understand effects-based and work back from that to say, maybe we should review our firewall rules in addition to this really complex monitoring solution so that we understand we're not just like handing the keys over.
People tend to like the idea that they can buy one tool or one new product and install it, and it will magically fix the problem. I guess in much the same way, that was probably the reason they bought the firewall in the first place. And it probably started quite strictly locked down, and then it just eventually evolved into being weaker and weaker and weaker to allow more and more functionality at the cost of safety and security. Would you agree with that?
I mean, that's human nature, right? We want silver bullets, and we know they don't exist, but we want to get as close as possible. The other thing I've seen is, again, human nature. We have very static policies and procedures. They have to be dynamic. So we have to evolve with trends, both offensive and defensive. And when I say something is static, that's not necessarily a dig at someone. These security teams are like overwhelmed, right? They're very busy. They've got all of these different priorities. Security is a function of a business typically. So there's all of these different factors at play. And so if I spent 6 months updating my, USB policy or my transient device policy, like I might not get a chance to look at it for another 3 years. I don't know how, your program is being prioritized, but the other issue is that nobody knows exactly what good enough looks like. I actually wrote a whole article about this. Like, there's a lot of places that tell you where to start, which controls might look right for your sector, your industry, which contingencies or, passes you might get. Like Rail has one in the TSA directives that says physical security actually can solve for this monitoring function that's part of this directive. We have some of that interplay, but there's nobody out there that says this is what good enough looks like and you will never be impacted again. And so that need for dynamic policies, procedures, reviews, updates, I think that's really overlooked from like a program management standpoint. I recently did a tabletop with a statewide organization, and when I reviewed their IR plan, I was like, wow, this is really, really minimal. And when I got there, they had so much more in play, right? They were really, they had a guy that was totally focused on AI. They were doing some like chip level analysis at the endpoint, like on security. They were doing really cool stuff. None of it was written down. And so that's a better problem than walking in and having like the paper say everything is great, and then you show up and they have nothing deployed, right? And they have nothing on paper. It's all fake, right? It's smoke and mirrors, right? That's
yes,
the worst case
checkbox certification.
Exactly.
A great evil of the modern world, isn't it?
Yeah, this was a better scenario than that, but you still do have to do change management and documentation and make sure that these things are dynamic and that they're coordinated. And there are some platforms for that level of orchestration, but I still think it's a people ownership model that we have to really have good management for, good leadership that says, I know it's been X amount of time since we did this, and we're actually going to build into the policy that we review this and recertify it or whatever, however you categorize that internally every 6 months or every so often. And so I think some of that program management is also catching up with how dynamic this needs to be in today's threat landscape.
Maybe this is a good time to talk about something that I know Joe and I are very passionate about, culturally, socially, and technically, and that is the notion of secure by design, which just sounds a little bit pie in the sky when you say it. But how can that help, and who should be responsible and how in a typical cyber physical network?
So even though I focused on legacy technologies at CISA, my counterpart, Matthew Rogers, actually focused on some of the modernization, I would say, of the OEM ecosystem. So there's actually a document called Secure by Demand for OT. I'm not sure if you've seen it, but it's priority considerations for vendors that's been published for, I think, 2 years now. That is the secure by design equivalent for OT systems. Things like memory safe.
That's the market end of it, isn't it? Where where the purchaser says, you know what, I'm not going to buy your system because I just don't think it's safe or secure enough.
Or when you go to, issue an RFP or bring in an integrator to select solutions, you can say, I want to cross-reference this. And there are some sector-specific examples of this as well. MTA in New York, the Transit Authority, they actually have a consortium that they run with tons of different transit agencies across the country. And they've actually written a rail-specific procurement guidance that incorporates actually more than the OT by demand does. It's actually longer and more detailed and specific because they're spending tons of money on these systems. So even though it's not a regulatory requirement to purchase X, Y, and Z based on the TSA directives, they can say if enough of us dictate that this is a requirement, then it's a requirement because we're all saying collectively, there's power in numbers, that we want this as part of our products. And so that's a different kind of push that's what we're seeing across the market. And that's just in one sector.
Now, Joe, you have some stats from surveys that RunSafe did in the past 12 months or so from healthcare and from automotive about the effect of security by demand, haven't you? Where asking people in various sectors, how has your own attitude to cybersecurity influenced your purchasing? Do you want to say something about what you measured and what people said? And
this was
more importantly, perhaps, where the costs should lie. Who should pay?
Yeah, this was a survey in the healthcare industry. And, part of the finding was that I think it was 46% of hospital systems were asking for and perhaps even making a no decision if there wasn't sufficient security in place. And so the secure by design nature and being able to ask for that is becoming an important thing. Now, with that said, I'm going to tease it out because the new study's coming out in just a couple of weeks here. But the early results are that number has increased even significantly in the past year. So it's gone up. And I'm very intrigued by the example that TJ offers in the transit, consortium, if you will, where people are developing, a collective voice to advocate for security. And so I think secure by demand, enables a level playing field of how to talk about some of these issues. And certainly organizations like New York's Transit Authority would have a leading voice and lots of experience. But having a common framework that is documented that people can talk about and get their arms around all the different aspects of security that could be demanded is very, very powerful coming from CISA out to all the organizations across the country. So I think it all works together in that sense.
This is another reason I was excited to get into the engineering and design world, not just because I love working with engineers, right? They're absolutely brilliant, And because cybersecurity is I'm a small fish in that larger pond, right? I'm not just a solution provider, like thinking about, what are our features do for our clients or our customers all day. But there are other examples too that we can build by design. And so the United States Coast Guard has a UFC facilities criteria for FRCS, facility related control systems. I published an article on LinkedIn about this because it's slightly overlooked because it's not enforced, but we're actually seeing that they're doubling down from a DoD or Department of War, DoW perspective now, where the new CIO has mandated you will do risk categorization and prioritization of your facility related control systems. You will invest in this. You will understand your vulnerabilities and actually keep track of those. And we build buildings, and we have a couple of DoW sites. And so I get to go in on that design, and at 60%, I work with the mechanical team and I evaluate what control systems are going to be in this building against that risk framework. And I understand, this is going to be considered low, medium, high. And these are the contingencies we want for when the builder, whoever we're partnering with, goes to build that environment. They either want to purchase something like this or something like that. And so it's really exciting to see this in action and not just on paper. And I've seen that actually, we're just kicking off later this week, one of our first Coast Guard projects on that. I'm really excited about. So that's a buildings example. But also, in the pseudo construction world, sometimes we're hired just to help organizations build the RFP. And so I can come in and say, hey, you really want to build cybersecurity into this RFP, here's why. If it's a hydrogen facility, right, a linchpin technology, there's really good guidance that came out of DOE for that. And so if you're doing it up front, you're probably reducing your costs down the road. And it might be more expensive who you actually, go with to build these really complex systems or buildings or facilities, right, whatever it is. But at the end of the day, if you're going to weigh that cost benefit analysis, we're going to build that into the RFP, right, for our clients. And if they don't want it, they don't want it, right? It's not a mandate. The other thing I'll say, so we have some of these sector specific and really exciting frameworks that we're starting to see being initiated more and asked for more. But the more negative, I think, trend, which is one I did see when I decided to leave government on my own volition, and I miss it. Honestly, I might go back someday. But the one thing I did see is that because there's a lack of sector specific regulation at the federal level and not likely to be more in the near future, we're seeing states now produce their own industry specific cybersecurity requirements. So New York has it for water and wastewater, New Jersey has it for water and wastewater, Texas has some different ones for military and critical infrastructure. Texas just launched its own cyber command. These are just two states, right? I know Nevada is doing some really interesting things around potentially mandating FedRAMP approved software. Like, we're going to see these states have all these different specific and regional requirements for procurement, for design, for build, for operation, and regulations. And you might have a company that operates in multiple territories. And so this jurisdictional, we called it regulatory harmonization when we were in government, but that was at a federal level. What does that look like at the state level? And how do we help people get ahead of that in a way that is cost effective? Because again, security is just one component of this overall design or development, right? And we have all these other cool things that go into the design that are just as important. This is kind of a tangent, but like, we have somebody here that has to conform to terrorism law that says like how high bushes can be outside of buildings now. And that person's just as important as cybersecurity. And so how do you weigh that all together in that early design phase? It's really important. And I think it'll make or break, the success of these facilities, events, trains, right, assets, et cetera. And so it just depends on the sector. But
and you've brought up rail a couple times, and I know you and your firm do work in the rail industry. And it's another example, if you think about all the different jurisdictions in which there is state-run rail or rail infrastructure, every jurisdiction has its own set of requirements in terms of how does the car communicate with the network, and what are the security requirements and expectations for delivery. And interestingly enough, in the U.S., the strategic rail network is vital for even the U.S. military. And I think there's 38,000 miles of railway in the United States. And I think at least 2/3 of that is used by the U.S. government to transport munitions and other things to different bases around the country.
And there's different requirements for freight versus public transit as well. Yeah. And then 100%. Depending on the communication system, so like CBTC is an evolving one. And then back to like sector specific regulations, there's actually a rail specific 62443 international standard coming out. It's supposed to come out spring 2026. So any month now.
Yeah, and that's the whole point, is harmonizing around that. And I do think when there's large stakeholders, perhaps the U.S. military in that sense, there can be a leader who can step in and try to drive those things. But there's also a need then to organize and harmonize some of those standards across jurisdictions.
The difficult thing, though, when we're looking at standards, again, I know we're on a tangent here, but I think it's an important one, is when we go in as a design firm and we're saying, hey, we're going to upgrade these DCS systems in this water utility, and they're super old, and we're going to go in and say, we have an in-house integrator, like I said, so we can go in and say, hey, here are 3 vendors you could go with. Here are the pro cons on the vendors. Here's kind of the historical I&E or whatever, integrator services we have in terms of like programming backgrounds, languages, et cetera. Pick your, your track. We could go and install that. And then we also have an entire communications team that does like new radio networks, right, that have different requirements now as well. But where does the upgrade end and the connection with the rest of the infrastructure start? That's a different strategic question as well, right? When we're kind of trying to look at these regulations and say, great, well, we've got this one project at this one facility, but then that connects back to, this Verizon infrastructure, or, whatever infrastructure that connects to this other facility. And so, wrapping our heads around, again, that continuous improvement, that due diligence, that effects-based interdependence mapping, like it is a constant. And it's not easy.
I'm really curious about your thoughts on this. And that is, within the aviation industry, the FAA made cybersecurity obviously a component of airworthiness. And so you think about that, the whole ecosystem to deliver a plane, and the manufacturer says, I've delivered you an airworthy plane, from a cyber perspective. And what then if a vulnerability does occur once that airliner has taken over that component? There has to be still ongoing relationship between supplier or manufacturer and the airliner in that case. But it's an interesting fact that they elevated air or cybersecurity as an airworthiness element. And in some ways that gives a North Star for everyone to point to in terms of what the expectations are.
We used to say when I was in consulting the first time around that there was like a 60-40 when it came to unregulated markets adopting new safety or any other kinds of options. And so 60% would wait around and see what the other 40% did in terms of North Star leadership. And then I would say in cyber, I would actually, maybe it's 80-20 or 90-10, right? If it's not mandated, it's not enforced, then everyone's going to kind of wait around and see, is that become a market point of competition that I need to invest in or not? Does it become a mandate or not? And they won't invest in it until they see how other people kind of sink or swim in that vein.
DJ, I'm conscious of time at this point. So we started out talking about secure by design, and it became quite clear that secure by demand, where people just say, I'm not going to buy the stuff that is insecure, whether the regulations require it or not, is at least as important a driver in getting security built in first, since we don't all have infinite money and infinite time to solve all problems at once. So to finish up, Joe and DJ, ask either or both of you, looking ahead, if you could propose or if you could advise our listeners on one change they could make right now that would help them do better, both to provide and to prefer to acquire devices and systems that are secure, what would that advice be?
Well, just to follow up on this airline example, because it's a perfect example, the procurement guidance and purchasing, procurement, all of those decisions have to follow a risk analysis, unless it's mandated, of course, right? The FAA can tell you X, Y, and Z. When I was at Nozomi, they were just starting to look at onboard systems for aircraft. Before that, where I work now in the building space, actually looking at the airports themselves was a different contingency, right? Because a lot of stuff was rented. It was, you replacing smart lighting that was efficient over time, but it was now no longer a CapEx. It was a service model. And so you're paying up front, and then that's another piece of connectivity from, this other system that has a different vendor. So you're introducing all these risks at the building and facility level. Now you're on board the aircraft. And then years ago, the risk used to be, what if we had a rogue transponder that you could now put on a drone and fly to manipulate the autopilot on an aircraft? And so that risk profile and perspective changes all the time. And that has to be what leads us into our procurement decisions, right? So I want to make sure that that's kind of the baseline. And so for me, when I do risk assessment, like I said, it's always effects-based. So my key takeaway is understanding interoperability, third-party risk, and the security activities and tooling that you have that are going to maximize your defense in depth instead of adding tons of data, right? To sift through for your SIM and calling it a day, right? Some of these activities that seem like one and done that are probably more static than you realize, and actually understanding how do I build these kind of constants that will actually enhance my security controls in a way that I have evidence to suggest I am reducing third-party risk, I'm reducing single points of failure, and I understand my interdependencies in a way that will prevent the worst case scenario in my environment.
DJ, could I summarize that, do you think, realistically, by saying very, very loosely and briefly, make sure you do the right thing for the right reasons.
Absolutely.
Don't try and do everything in the hope that you
don't boil the
one
ocean.
that works.
Exactly. Yeah. And then Joe,
Great.
I'm sure you've got something brilliant to say.
Yeah, on demand, I have something brilliant to say, which is listen to DJ. I think she's very, very smart. And this has been an excellent episode. But nonetheless, I do, joking aside, although that's true, I do think that, defense in depth is key. And, finding ways to work with your vendors, with your suppliers, and really kind of take it as a holistic view. So if you are doing that effects out analysis, then share that and use it to help justify why you're asking for things, and don't just demand them, even though everyone should adopt secure by demand.
Yep. And add scenarios and tabletops, and you're in a good place.
And Joe, would you agree that one of the key things that we all need to do, whether in IT and OT, is to try and build a world in which we get ourselves off this basically patch everything, patch often marathon treadmill?
Yeah, I think it's impossible to keep up with the patching requirements. And certainly in this distributed infrastructure, as we highlighted in this podcast, it's almost impossible to ensure that patches will be there. So we do need to think about how to add in security so that you're not relying on chasing vulnerabilities and patches, but you're staying ahead of the threat.
Joe and DJ, thank you so much. I wish we didn't have an end time that we had to hit. It feels like we've just got going and now we could start having the real discussion. So maybe there's a great opportunity to dig into some of these issues in future episodes. Thanks so much for your passion and your intelligence and your excellent advice. That is a wrap for this episode of Exploited: The Cyber Truth. If you like this podcast and find it useful, please don't forget to subscribe so you know when each new episode drops. Please like and share us on social media. If you listen on a podcast feed, please write us a nice review. That really helps us get the message out. I'm sure you can see from this episode that this podcast series is not a sales spiel. It is a community engagement podcast. So thanks to everybody who tuned in and listened. And don't forget, stay ahead of the threat. See you next time.